acidification for 1,700 days.
The process by which greenhouse gases produce climate change and other weather phenomena involves several key steps. Here's a detailed explanation of how this process works. Solar radiation and Earth's energy balance. Incoming solar radiation. The sun emits energy in the form of solar radiation which reaches the Earth. This radiation includes visible light, ultraviolet light, and infrared radiation. Absorption and reflection. About 30% of the incoming solar radiation is reflected back into space by clouds, atmospheric particles, and the Earth's surface, especially ice and snow. The remaining 70% is absorbed by the Earth's surface and the atmosphere, warming the planet. Re-radiation of heat, infrared radiation. The Earth's surface, after absorbing solar energy, heats up and re-radiates this energy back into the atmosphere in the form of infrared radiation or heat. Escape of heat to space. Some of this infrared radiation escapes directly into space, helping to cool the Earth. Role of greenhouse gases. Greenhouse effect. Greenhouse gases in the Earth's atmosphere, such as carbon dioxide, methane, nitrous oxide, and water vapor, trap some of the infrared radiation emitted by the Earth's surface. This trapping of heat is known as the greenhouse effect, absorption and re-emission. These gases absorb the infrared radiation and then re-emit it in all directions, including back towards the Earth's surface. This process keeps the Earth's surface and lower atmosphere warmer than they would be if the heat escaped directly to space. Enhanced greenhouse effect. Human activities such as burning fossil fuels, deforestation, and industrial processes have increased the concentrations of greenhouse gases in the atmosphere. Higher concentrations of greenhouse gases enhance the greenhouse effect, trapping more heat and leading to a warming of the Earth's surface and lower atmosphere. Climate change and weather phenomena. The enhanced greenhouse effect leads to an overall increase in global temperatures, commonly referred to as global warming. The increase in temperature affects atmospheric and oceanic circulation patterns, leading to changes in weather phenomena. Some of these changes include more frequent and severe heat waves due to higher average temperatures, changes in precipitation patterns resulting in more intense and frequent rainstorms and flooding in some regions while causing droughts in others. Warmer ocean temperatures provide more energy for tropical storms, potentially increasing their intensity and frequency. Higher temperatures cause glaciers, ice caps, and sea ice to melt, contributing to rising sea levels and affecting polar and mountainous regions. Melting ice and the thermal expansion of seawater as it warms led to rising sea levels, which can cause coastal erosion, increased flooding, and displacement of coastal communities. Increased CO2 levels not only trap heat but also dissolve in seawater, forming carbonic acid. This process lowers the pH of the oceans, affecting marine life, especially organisms with calcium carbonate shells or skeletons. Feedback mechanisms. Certain processes amplify the effects of global warming. For example, as ice melts, it exposes darker surfaces like ocean or land that absorb more solar radiation, leading to further warming and more ice melt. Warming causes permafrost to thaw, releasing stored methane and CO2, which further enhances the greenhouse effect. Some processes mitigate the effects of global warming. For example, higher CO2 levels can stimulate plant growth, which in turn absorbs more CO2 from the atmosphere through photosynthesis. The process of greenhouse gases producing climate change involves the trapping of heat by these gases, which leads to global warming and subsequent changes in weather patterns. The enhanced greenhouse effect, driven by human activities, results in a range of climatic and weather phenomena, including more frequent and intense heat waves, altered precipitation patterns, stronger hurricanes, melting ice caps, rising sea levels, and ocean acidification. Feedback mechanisms can either amplify or mitigate these changes, further complicating the dynamics of climate change.